Hello, hello. It is so good to be back with you all. Hello, hello, hello. Welcome to the Luniverse. I'm Dr. Charles Liu, your host. And as you have all these years, please call me Chuck. We have such a marvelous episode today. I am just so happy to be here and to reintroduce our co-host, as always, Allen Liu. Hey, Allen.
Hello.
Hey.
Hello.
Have you energized any non-internal combustion engines of late?
Oof. Let's see. I have. Well, I mean, my car is a plug-in hybrid, so that's
Aha!
something that
So
half
the
of the
answer is
time it's
obviously yes.
yeah. I'll have to
Marvelous.
figure something else
Right.
out, maybe, but that'll do for
Well,
now.
I'm just mentioning that because our cosmic cool thing of the day has to do with something called a radioisotope thermoelectric generator. But never minding that, let's introduce our wonderful guest for this episode, Dr. Kelly Blumenthal. Hi, Kelly.
Hello. Thank you
Hi.
for having me.
Y'all, it is such a pleasure because we are honored by your presence. You are the director of the Office of Astronomical Outreach at the International Astronomical Union. This is like the longest title of anybody we've ever had as a guest. And so I can't wait for you to tell us all that sort of stuff. You want to tell us a tiny little bit about what you're doing now, where you are, and the kinds of things that you're focusing on before we get on to our joyfully cool cosmic thing of the day?
Absolutely. So I am tuning in here live from Tokyo, where
Hey!
the Office for Astronomy Outreach is based. We are housed at the National Astronomical Observatory of Japan in Mitaka. And if
Ooh,
you ever happen to be in Tokyo or anywhere in Japan, you should come on by because the campus is actually really beautiful. There's a ton of
That's
historical
awesome.
telescopes and observatories, and you can walk around the campus for like 2 hours and not see everything. So it's really,
wow.
really cool.
That's fantastic. Yes, Japan and all the rest of the world, right, has a long tradition, especially Japan, of astronomy and discovery and things like that, right?
It's true. Yeah, they absolutely do. It's many places all over the world do.
Yeah. And so I'm excited that you are coordinating that message for all of us astronomers about all the cool things we do. But yes, let us go to today's joyfully cool cosmic thing of the day. I said day twice, didn't I, Alan?
Today's joyfully cool cosmic thing of the day isn't the worst mess up that you've done or that I've done,
Oh.
apparently. So
Very good. And it is a joyfully cool cosmic thing indeed. The Mars Perseverance Rover, which is powered by a radioisotope thermoelectric generator, not
yeah,
internal combustion, right?
it's hard to do internal combustion on
That's
Mars.
right. That yeah, with a very, very, very thin atmosphere. That's right, which doesn't have much oxygen at all. The Perseverance rover found a rock called Sapphire Canyon, and this rock contains biosignatures. Maybe.
Like pretty probably, but not 100%
Right.
guaranteed biosignatures.
As scientists, we should always be skeptical and we have to test, but it contains potential biosignatures, right? Alan, is there something, specific that makes us feel like this cool thing is even cooler than other things with previous potential biosignatures?
Yeah, so in the past, we found things like lots of different kinds of rocks with chemicals in them, basically, that on Earth are formed by life. And there might be other ways that those same minerals could have been formed on Mars and that not by life. This particular one, the trick, I believe, is that they found these little nodules. On the inside, there's iron and sulfur. And then there's this layer of stuff. And on the outside, there's less iron and sulfur. Or it's the other way around, one of those two.
Mm-hmm.
And the trick is that on Earth, there's this whole kind of bacteria that eats iron and sulfur and basically chemosynthesizes them. So it's like photosynthesis with plants using light to make food. These things use chemicals to make food. And there's not really any other ways, at least on Earth, or even like in our labs, based on the conditions we expect to find on Mars, that this iron and sulfur could get converted into these new minerals in layers like this. So it's possible that there's some just chemistry that we don't yet understand that did this, billions of years ago, potentially when Mars was wetter and warmer and so forth, and more atmospheric. But the best guess, if we saw those rocks, say, in a desert on Earth or something, would be that this was from bacteria. So
Wow.
it's really cool. Like it's not a slam dunk, absolutely that's life, but it's definitely, like a 3-pointer or something.
Wow. Fantastic. Well, look, this paper was indeed not just speculation, but it was published in a peer-reviewed journal and it's been examined by colleagues. And so this is not just someone saying, hey, this could be. This is like legit actual science, but it could still be wrong, right? Kelly, what do you do when you are, let's say, presented with such an amazing discovery? How do you tell people the right thing without like misleading them or giving them false hope or crushing them before you
Yeah, you don't want to underhype it or overhype it, right?
Right.
Yeah, it's true. It's true. And one of the biggest like things that people think about in science communication is communicating uncertainty, and talking about the true, scientific process, and the thing that you learn in school that, you have a hypothesis, you do the methods, you do all these things, and there's an order that you have to follow, is often, almost always, not how science actually works. And so what we try to do is talk about uncertainty, talk about how science is kind of like a, and like in a painting, you paint something once and then almost always you have to go back and you have to fix some things. And it's kind of like a layering process to create the overall image that you see. And that's very much like what science is. You're constantly reforming to make a clearer picture or maybe even a different picture than what you had before. So it's, there are ways to explain things like this that are really exciting, that get people really hyped up. Because you want to, kind of feed into that in as much of a way as you can. But you also want to be truthful to what is
Right.
maybe likely the case.
Yeah.
That makes so much sense because, when we are talking about these cosmic things, the first thing we do is like, yeah, they're aliens, man.
I mean, yeah.
Yeah, these are first drafts, aren't they? In the same way that a novel goes through many iterations to make sure that it's its best thing. Or like you said, a painting isn't just something that Monet or Van Gogh put on the canvas and they were done. There's still much to do. What more needs to be done in something like this before like you really feel happy and say this is a scientific discovery for real?
Well, I would think, one thing that would be really compelling is that if another one of those rovers in a different part of the planet found a similar biosignature.
Yeah.
That would be super compelling to me.
Because
then it's not something
the same
that's
process in different
specific
places.
to, yeah, exactly. The same process on a different spot on the planet, but also not the same rover that's making this assessment or, making this measurement that then the scientists are assessing. But it's, kind of like when you have one scientist making a claim and then the experiment being repeated by another scientist. And if it's repeatable, then you can be certain, or more certain than it's
more certain.
something that's
more certain.
Something that's actually true.
That makes total sense. That's really good. Kelly, you have shifted your professional work a little bit from what you started some years ago. And it's great for me, in my opinion, that astronomy is so multifaceted that you can be an astronomer and do lots of different things. Tell us a little bit about like the science you were doing, the research at first, and then your path toward shifting over to what you're doing now, which is really the science of science communication.
Yeah. Well, I have a PhD in astronomy. I also have a master's degree in education, but that came later.
Interesting.
And during my PhD, I was always doing public engagement events. I did a lot of stuff working with the community. I did my PhD in Hawaii, between Hawaii and Cambridge and Massachusetts, and it was one of the most fulfilling things for me working with those communities and working with those students. And it was when you're working on your PhD, everything is just so heavy. And working in these engagement events and actually like interacting with people and talking about science was one of the ways that I kind of pushed myself through my PhD. It made me feel so much more like what I was doing made a difference and was important. So for the work I was doing, the way that the structure is in the University of Hawaii is you do a master's project, 2 master's projects, one in your first year, one in your second year, and then you continue on to do your PhD project. And usually they all have something to do with each other. But so my first project was on what's called Jellyfish Galaxies. So these galaxies that are moving through the outskirts of a galaxy cluster and interacting with the gas, and the gas in the galaxy itself is being ram stripped out and kind of turning into these tendrils that are coming out of the backside of the galaxy.
Sounds painful, being ram stripped. Ouch.
Oh no.
but it turns
does
out
sound painful.
It does, but it turns out that the streamers are still there then, and you can actually see that it was in fact ram stripped because of this gas that's left behind.
Yeah, it's really, really interesting. Those super interesting objects, and I was looking at star formation rates in those objects.
I love star formation rates in weird galaxies.
Yeah.
So, Alan, let me just make sure we will put in the YouTube video part version, the video version of this episode, we'll put some pictures of Jellyfish Galaxies, okay?
Yeah, we definitely
so that people
will.
can see exactly what they look like.
So if you're just listening to this on the audio version, feel free to hop on over to the internet and see the video version so you can check out these pictures.
And check out the YouTube stuff. Yes, absolutely. And also check out Dr. Blumenthal's awesome curtains in the background.
Yes, of course.
And the fact that we are in nighttime and she's in broad daylight because Tokyo. That's awesome. Anyway, yes, please. Kelly, please continue. So Jellyfish Galaxies, which led me to well, it didn't really lead necessarily, but I was always really interested in galaxy formation and evolution. Actually, I think when I was like 12, I told my dad I wanted to study galaxy evolution, and he was like, "Okay, you're 12, you don't know what you're talking about." But I started working with a professor at University of Hawaii, Joshua Barnes, who is one of the most amazing people that I've ever met. And we were doing projects related to galaxy interactions. So merging galaxies that kind of skirt past each other, and different formations of those galaxies, and seeing what popped out. And then I kind of took that a couple steps further, and I wound up looking at the history of merging galaxies through cosmic time from large cosmological simulations.
Oh, nice.
Wow.
So all of this was, it's really kind of heady when you first think about it, but it's such a visual field.
Yeah.
That it's actually, I think, a little bit easier to follow. I did an interview once during my PhD where I described galaxy interactions like a tango.
Ooh, nice.
And, because you're very close, and the way that you interact with each other is very much like the way that galaxies move around and interact in that way.
So tango, as opposed to what I've heard is other people calling it a cosmic ballet.
You could call it.
I actually like tango better. Yeah, because it's much more dynamic, right, and energetic, and not quite as well disciplined as ballet.
Yeah, I think that's very true, and that's certainly true of galaxy interactions. And but it does depend on what kind of interaction you're talking about. Depends on how they come together, the way in which they're rotating as they come together, angle, of course, of that interaction. So it's very interesting and complicated. And yes, it
Wow.
takes two to tango, but not to ballet. Well, sometimes it takes more than one person to ballet, but that's true.
That's true.
Not exactly, too.
Not exactly. And I have to agree with you of your opinion of Josh Barnes. Really just a great person and one of the giants in the field of computational astrophysics. I mean, he, along with Pete Hutt, 4 decades ago, created almost our modern computational techniques, which we're still using today, but in a much more advanced version with much, much more advanced technology. But just Josh is just a great guy too.
I was
That's
super
wonderful.
lucky to work with him. Yeah.
Well, I'm sure he was super lucky to work with you too. But then you shifted, right? You after Hawaii, you went to Harvard and got this master's degree in education, right?
Yeah.
Was that like a natural progression of your doing outreach and community events and so forth, and just like this was where you wanted to concentrate your astronomical energies?
Yeah, it really was. So, it's obvious when you're working with any communities, there's always going to be a spectrum of people who have access to resources and people who don't. And that spectrum is often dictated by the policies that are in place.
Right.
And
That's
so
real.
what I not specialized in, but the degree program that I was nominally a part of was the education policy program.
Education policy and management?
Yeah.
Oh, cool. Should we tell Alan?
I don't know. You can say
Your
if you want.
sister,
Who has
Hannah,
been a guest on this
who
show
has been
before.
a guest on the show several times, indeed also has a degree from exactly that same program, but probably a few years after you were in it. So if you're EPM, we're like, you're like extra awesome in our eyes. That's awesome, Kelly. That's just great. So we are going to get an audience question in just a moment, but first we're going to take a short break for advertisements. We'll be right back in just a little bit with Dr. Kelly Blumenthal here on the Luniverse. Hey, we're back on the Luniverse here with Dr. Kelly Blumenthal, who runs the Office of Astronomical Outreach of the International Astronomical Union and is based in Japan. We are so psyched to have you here, and you are the perfect person to have us ask this audience question. Alan, what audience question are we going to provide for Kelly?
Yeah, so this is from one of the IAU's more public moments in history. This question comes from Jeannie, who is Jeannie a student? Is that correct?
Yeah.
Okay, this is a student question from Jeannie, who is asking, now that we've found so many planets outside of our solar system, should Pluto be promoted as a planet again?
Ooh, yes. Pluto's demotion by the IAU more than 20 years ago, roughly 20 years ago,
More of a
was
lateral
huge,
move.
Yeah, was a huge issue. And many people did take it as a demotion and they've been upset about it for a long time. Kelly?
It's not a demotion, it's a reclassification.
Okay.
So I talk about this because Pluto is an amazingly cool planet, dwarf planet.
Oh, wait. Oh no. Okay.
Dwarf planets might be planets the way dwarf stars are stars.
But it is really, really cool. There's so many interesting things about it that we learned about also with New Horizons. And it's way more geologically diverse than we ever could have imagined. And it's got a little heart on it, so cute. But it is different from planets. So no is the short answer to that question. It orbits the sun.
Yeah.
That's one thing that it has going for it. It is mostly round, which is another thing it has going for it. But there's a bunch of stuff in the way. And that stuff hasn't been cleared because of, the fact that it's a dwarf planet. It's not large enough. So it's not going to be classified as a planet. And before anybody talks about Jupiter with all of its planets.
You mean the Trojan asteroids?
Moons, you mean? The Trojan asteroids and all that?
Moons, oh my goodness. Everybody's a planet.
We are all planets.
But, it's a very different formation process. So a lot of those moons were captured by Jupiter. So it's not the same formation. The material in the outskirts of the solar system is, the remnants of solar system formation. And that's a very different process than material being captured by a massive planet.
Yeah.
So Pluto lovers are going to continue to be disappointed because it's just a dwarf planet. Is that what you're telling us, Kelly?
It's not just a dwarf planet. It is a dwarf planet.
Oh.
Yeah, they should be proud of being a dwarf planet.
Exactly.
Oh.
Because it's its own classification of a really cool object. And it's the first of its kind, in fact.
Yes, that's true.
So things get reclassified over time, as we get new information, right?
It's that painting that we're talking about.
Huh.
Yeah, exactly. That makes a lot of sense. I'm gonna be a little bit pushing on this because I've heard an argument, which is that because Pluto takes so many centuries to orbit, it's so much farther out, it's got so much more space it needs to clear because its orbit has this longer path, and it's had much fewer orbits to actually do it, to actually make that clearing happen. So there are people who are arguing, like, if Earth was out somewhere past Pluto, maybe it wouldn't be able to clear its neighborhood either. Would that make it a dwarf planet in that case?
Well, it's a size issue. It's not a difference in the position from the Earth. Oh, sorry, the position from the sun. I don't know what I'm talking about today.
Because there'd be so much less time for fewer orbits for it to actually make a difference, right? So it wouldn't be able to clear its orbit before today or something. Maybe billion. Yeah, that's true. Maybe it would have been enough time anyway.
Well, and then maybe it would have, the orbit would have been perturbed enough to move things out of the way. That's maybe true.
That's fair.
But that's not the way it is now. And maybe we can revisit in another billion years.
That's fair.
With things change.
Okay. So Pluto lovers, just be patient. A few 100 million years from now, who knows?
Or maybe we'll have an even cooler classification than either planet or dwarf planet. It'll get to be that sometime in the future.
Maybe we'll realize that planets are actually sentient and they'll be, organisms unto themselves.
Are you
like the Green Lantern planet?
Wow, that would be so awesome. Actually, yeah, Kelly, are you a reader of science fiction? Do you like that kind of stuff?
Absolutely,
Really?
I do.
And
And I'm actually thinking of a Star Trek episode where they find sentience in kind of like a crystal.
You mean Devil in the Dark, where the
Yes.
Horta?
Yes.
Yes.
Oh, wow. Okay.
Yes, that's one of the original series. Yeah.
Mm.
Uh-huh.
That was then, I think, recreated in The Next Generation.
Yes, where they were like ugly bags of mostly water or something like that in the first season. Yeah.
Or we were the ugly bags of mostly
We were the
water.
ugly bags of mostly water, right. Whereas they were like the actual life forms that were crystalline. And there was a crystalline entity, right, which was highlighted in the episode Silicon Avatar, which then was made into a sort of allegory, like, is Data actually, the android also a silicon avatar of life, et cetera, et cetera.
Interesting. Yeah, because he's made of silicon.
All kinds of
positrons. But
right,
yeah.
so that's like Star Trek: The Next Generation. Oh, okay, you've gotten us on Star Trek. We can't get off of it. That's just the way I am. I'm sorry, Kelly. But yeah, tell us about some of the reading that you like to do. Some of the cool stuff that maybe you might recommend to our listeners that we should poke in on as far as literature and stuff.
Well, I haven't read any sci-fi recently. When I was in high school, I went on a really big sci-fi binge. I would choose a series and then read everything in that series.
So, amazing.
2001 Space Odyssey, the Foundation series. I read
good.
everything that I could get my hands on.
Wow.
Actually, I did do that relatively recently with The Expanse.
Nice.
Which is really, really good. I was listening to it on audio. I've listened to it 3 times over.
Wow.
There's a lot of books.
Great.
It's a lot of time.
That's amazing. Yeah. No, we've discussed The Expanse here on the show over the years, especially with Jimmy Negus, one of our first guests, right, Alan? About the solar system and what will happen, and then it suddenly just jumps beyond the solar system and turns into this sort of super cosmic situation. So
yeah, there's a lot of really cool stuff about
wow.
People put it up there with the science fiction series of days of the past that people think are gonna last.
Really?
Yeah,
you mean like 2001, like a Space Odyssey?
Maybe not quite as high up as 2001, but
Dune?
Pretty high up.
Yeah.
Dune.
Well,
Dune kind of jumped off the rails at a certain point, but Dune
Yeah.
was also very good. But I
Yeah.
think those, the movies that are associated with those novels help to
Mhm.
make it as timeless as possible because it really focuses the internal narrative that you can have
That's
about the
very
movie.
true.
Oh, that's a great
So,
point.
So like
Yeah.
yeah.
Kubrick's 2001 is, this whole big thing too.
Oh,
So
Yeah.
that's true. The
True.
movie 2001. Well, that and the book were supposed to be like experienced in parallel, right?
right,
I guess
yeah.
because there's some things you can see on the page that you can't see
Yeah.
on the big screen, and vice versa.
So yeah,
Mhm.
and the stories are very slightly different too. Like one's at
Yeah,
Jupiter,
they
one's
are.
at Saturn, like stuff like
Oh, I
that.
see. Okay, okay. So that's all part of the communication thing, right, Kelly? I mean, talking about science and the astronomy of stuff and tying it in.
Mhm.
Is that how like you approach the science communication and the science thereof? Like, what can you teach me how to communicate the stuff that we love about the universe to people? What should I
Right.
know as a scientist trying to communicate?
Well, you should know who you're talking to,
Aha.
and cater everything that you create, everything you provide, everything you do to that audience. If you don't know who you're talking to, you might as well not be talking to anybody because you're not going to reach
Yikes.
people in the way that they should be.
Wow.
And that goes for, every aspect from what language are you talking in to the level of the resources that you provide,
Mhm.
to the way that you interact with people. Are you speaking to an audience of people who are blind or low vision?
Hmm.
Um, because then, talking about images, you have to approach differently. And this was actually a workshop that we did a few years ago with the people from the universe of sound is associated with it, but they also do a lot of other stuff with tactile models and rich visual descriptions um, of astronomical images. And this is through the Chandra telescope.
The X-ray one, yeah.
Yeah. And so what you can do is in a very detailed way, describe precisely what you're seeing and how. But even when you're doing something like that, you need to understand the cultural context, the environmental context. Because
Wow.
one example that I'm thinking of in particular describes the nebula as looking like tires and snow. But if you live in
Oh.
somewhere that's primarily desert, you
Uh-huh.
don't know what that looks like.
Huh.
So, or you don't know, you can't experience
Imagine
it. You
that,
don't,
yeah.
not even just imagine, but in a tactile way, what could that possibly mean? Or
Right.
even if, you've
Makes a lot of
not
sense.
been low vision your entire life, or if
Uh-huh.
your low vision is good enough for you to experience something like that, or
Wow.
experiencing color, it's a very different thing. So
Oh,
that's just a
right.
very small example of how you can cater things to the people that you're actually speaking with.
Wow.
But it's not just science fiction, I think, that
Mhm.
helps us move through communicating with people
Okay.
in astronomy and science. I
Oh.
think it does. I think the thing I love about science fiction is that it's a social commentary every time.
Mm.
Hmm.
No matter what you're reading, there
Yeah,
is
true.
an undertone to it. Often not even an undertone. It's the main point
Yeah, a
is
lot of the time.
something that's very profound and deep to the way that society works or doesn't work. Um, but in other forms of literature and art, there's so many different ways to approach science that scientists might not even think of. You can approach it from a poetry perspective. You can approach it from
Right.
music. You can approach
Yeah.
it from paintings and dance and theater. There's so many different modalities of understanding the universe, even
Wow.
smell. I saw a talk given by someone who was working with incarcerated kids, and you can't bring anything in there really. But what he could bring was, like little samples for people to smell. So
Uh-huh.
there's, the center of the galaxy smells like raspberries. The same chemical is the same chemical in the center of the galaxy that and it's similar enough that it smells like what a raspberry
That's
smells like.
amazing.
And so you can
Wow.
bring people into the conversation in that way, given what you're physically capable of explaining to them, bringing to them, and providing them. So
That is so
Yeah.
cool.
That's incredible.
Whoa.
I would not have thought of that.
Now, if only we could actually get a smell-o-vision YouTube thing. We could smell the raspberries on the screen.
That would be
be
really
so cool.
That would
But
be great.
That makes so much sense, though, Kelly. That's really, really neat. Do we have another question?
Yeah, we do have another question. This question comes from Bridget, who is asking, so is that comet actually an interstellar spaceship?
Oh,
Speaking of detecting chemicals and things and
that
all the
comet,
way.
huh?
that.
Okay, Kelly, maybe you should tell us all about that comet and this whole spaceship thing. I know it's been in the news lately.
Yeah.
Yeah.
Alex.
Save us.
It's not a spaceship. It's
Okay.
just a space rock. It's a space rock. It's not just a space rock.
Exactly.
So, I mean, it did come from outside of our solar system, which is a really amazing thing, I think. I was actually writing about this recently.
Oh, really?
Voyager spacecraft
Mhm.
left the heliopause in 2012.
Okay.
And
Yeah.
3i Atlas entered the heliopause in 2017. And
Oh,
so
so
it's
this is
almost
called-
like trading
Oh, neat.
objects within our solar system, which I think is super cool. And it
All
puts us all in perspective, Like, we're not the only solar system out there. And here's the tangible proof. And I think it places our solar system and our planet in a really beautiful perspective that is being sullied by certain people who claim
no.
That that's a spaceship.
that it's a spaceship, or that it's a
that-
light sail, or that it's carrying things that are going to destroy our planet. Whatever they're saying at the moment is wrong.
Wow.
Almost
that-
certainly wrong. I should
Wow.
say.
Because we've seen 3 of these in the past, 5 or 6 years or whatever it's been, right?
Well,
so
it's called 3i Atlas, right? Because
Yes,
it
3i
is the
Atlas.
third one
Because
that's
it's
been
the
seen.
third.
Yeah, the third
Yeah.
interstellar object. There was one that
Uh-huh.
was like a weird flat asteroid. There was another comet, 2i Borisov or something like that. And then there's this one. You can't have 3 spaceships go through the solar system and not say hello to us. Like, come on, man.
I guess that's true. But yeah, Kelly, you use the word sully, which is really quite amazing to me. That the beauty that you see in the solar system and in our galaxy is somehow made less by claims of these being extraterrestrial vessels. I mean, why do you say that the idea that they are alien vessels is somehow not as beautiful or not as cool? Is it actually that information, or is it the way it's being said that's bothering you?
I mean, it's the way that it's being communicated. It's the way that it's being approached. If this particular person approached it from a perspective of, what if it were this? What could we see? What would we know could be there? What are the implications that might happen? And approaching it from a much more scientific perspective rather than just stating that this is obviously true. But also at the same time, I think it distracts from the narrative. It's not. That shouldn't be the dominant perspective. I don't think that's what people should be talking about. I think people should be talking about this amazing discovery and what it means for our perspective and us as like a global citizenry,
Yeah.
There's so much more to it than just saying it's aliens.
Yeah, I mean, one of the things in terms of it not currently being aliens, but there was this idea, we talk about the idea that life on Earth might have originated in other places, right? Like maybe it came from Mars, or maybe Earth and Mars were both seeded from some other place, going back to our, Mars microbes discussion, potential Mars microbes discussion. Now that we know that rocks can make it from one solar system to another, maybe it's more possible that, bacteria or little tiny life forms might be able to make it from one solar system to another, without it being a conscious spaceship. And that, to me, I think is one of the coolest things about finding all these interstellar objects.
Oh,
Yeah, absolutely.
That it lends some idea to it gives us some more information that we can use to build this theory, whether it happens to be one that's correct or not. But it's information that we can use to make a judgment on that.
that makes so much sense. So, Kelly, from the OAO perspective, how does the International Astronomical Union get that good message out as opposed to the sullied message of individuals who want to claim it is so without following the science.
Yeah.
What do you guys do? I mean, how do we solve this problem?
Well, it would come from my office. So,
Yeah.
and I think, one of the best venues to discuss something like that is actually an event that's coming up at the
Ooh.
beginning of October.
Oh, what's that?
It's 100 Hours of Astronomy,
Uh-huh.
which is a 100-hour marathon of events that are happening all over the world. It's really an opportunity for us to kind of gather together and just learn about the sky, learn about space, and just try to understand our place in the universe. And one of the things that we're doing as a really special event is a 24-hour live stream from a planetarium in Japan. Not just any planetarium, it's actually the oldest functioning planetarium in Japan.
Wow.
Oh, wow.
The Akashi Planetarium.
Very
And
cool.
we're going to be there live streaming. You can find it on our YouTube channel. And it's going to be a great time. So that would be, and that is a really great venue for us to try to engage with people and talk about all of these things. The recent discoveries from the Martian rover to the Three-Eye Atlas. There's so much rich material that we can talk about.
Okay.
Yeah, there was the loudest black hole merger in terms of gravitational waves recently too. Like,
Yeah,
there's a bunch
There's
of
so
cool
much
stuff.
good stuff to talk about. I agree completely. So that's a really smart, I think, Kelly, in my opinion, that your office is engaging people and making the fun thing happen, right? Let's be sure to put in the show notes the episode for this episode, Alan, about the 100 Hours of Astronomy on YouTube.
Yeah, hopefully we can get it up ahead of time. At the very least, we can post it all over the socials.
Yes, I think that'll be wonderful. And if we want to find out more, we can go to the YouTube channel for the IAU also, Kelly? Is that where it is?
it's for the OAO. So I can also
OAO
send you
specifically.
the link directly to the live stream where we'll be.
That would be fantastic. Please do. Office for Astronomy Outreach. That's just great. Oh my gosh. We could go on and on and on, but we really are running out of time. Kelly, if we want to follow what you're doing, aside from that OAO page that we're going to put in the show notes, how can we keep track of the cool stuff that you're doing in general? Is there something on the socials or something that we can find you?
Yeah, absolutely. So we have a website, IAUoutreach.org.
Okay.
You can find us on Facebook and Instagram and LinkedIn. We do have an X account that we are straying away from. But if you find us on those primary socials, we'll be there. You can come follow us, and you can find me on LinkedIn. It's probably the best place to find me.
Okay.
And I'm very happy to talk with people about whatever it is they'd like to talk about. And also, if you have any questions about Pluto in particular, or stars, naming stars is also another one that we get all the time. You can email us at public@oao.iau.org.
Well, this has been so fun. Dr. Blumenthal, Kelly, thank you so much for being with us today on the Luniverse. It has been such a pleasure to have you. Please come back, okay? We'll talk more in the future about all kinds of stuff. Thank you so much.
Thank you. Thank you for having me.
And as always, our co-host, Allen Liu, thank you for everything that you're doing, make this show work and everything. It's always such a pleasure. Thank you.
Yeah, of course. I'm so glad to be here.
And for all of you in the audience, thank you for being with us today. If you like what you see or hear, please support us on Patreon. And as always, thank you for being a part of the Luniverse.